All right, today we're looking at natural log integrals. Now notice I'm not saying the integral of natural log because that's not what we're actually doing. We're taking the integral that gives us natural log. We can't take the integral of natural log yet, that's in the future. So yesterday we talked about this, that the integral of 1 over x is going to be natural log absolute value of x plus c. But what this means is that if it's just 1 over x, it's natural log absolute value of x. But if it's u substitution, we have to be able to make our whole denominator u, and then our du has to be on the numerator. So, looking at this one right here, this very first one, we want to make our whole denominator u, so u is 3 minus 4x. Du would then be negative 4 dx. So we need the inside multiplied by negative 4, outside by a negative 1/4, integral 1 over u du, and so negative 1 over 4 natural log absolute value of u plus c. So negative 1 over 4 natural log absolute value 3 minus 4x plus c. All right. Now, some that are fractions are not always natural log. For example, this one right here looks like a fraction. You're thinking, oh, fraction, natural log, but it can just be split up. This is 3x plus 2 over x. So the whole thing wasn't a natural log. Integral of 3x is just 3x squared over 2. But the integral of 2 over x, that one is going to be a natural log. So 2 natural log absolute value of x plus c. Sometimes you're going to have something really ugly and massive like this, and it's going to be hard to identify what your du is. So let's take our u. We got x cubed plus 3x squared minus 4. So our du would be 3x squared plus 6x dx. So if we multiply this in, we have x squared plus 2x, which means we almost have our du there. We just need to multiply it by 3. So we need the inside multiplied by 3, which means outside multiplied by 1/3, 1 over u du. Integral of 1 over u is natural log absolute value of u plus c. And then we can plug back in our u. Natural log absolute value of x cubed plus 3x squared plus 4 over 3 plus c. A lot of these are just more practice, but I want to talk about both of these very quickly. So this one on the left, we would make u natural log of x, because that's being raised to a power, and then our du would be 1 over x dx, which we have hanging on the outside. So if we rewrite this, this is natural log of x, whole thing cubed, times 1 over x dx. The one issue a lot of people have with this one is they try and say this is x cubed and pull the 3 down to the front. This is not just x cubed, it's the whole natural log of x cubed. All right, so this would be our u, this would be our du, and then we can integrate. This one over here is an integral that we've talked about before, as in one that we can't do, but we can do it now. If we change this to cosine over sine, well, we can make u sine of x and du cosine x dx and do a u substitution here. We can say this is 1 over u du, which is natural log absolute value of u plus c, or natural log absolute value sine x plus c. So now we know what the integral of cotangent x is. It's going to be natural log of sine x plus c, absolute value of sine x plus c. All right. Now, this one right here is the only one that's a little more complex. And I'm going to tell you how to do it, but I'm not going to go through the time to do it right now because I don't have all the time in the world. You are going to have to do long division here, which means you're setting x minus 3 to the outside, x cubed minus 3x squared plus 5 on the inside, and then you're going to do your long division, and you're going to end up with some terms, and then your final term is going to be something over x minus 3. This is the only part that'll have to be u substitution. And this would be your remainder. What's out here is whatever you get on top. That goes there. And then you should be able to integrate it after doing long division. Okay. Last ones I want to talk about are ones where you have to use substitute with these, or where you have bounds with these. So first off, we're going to 2 our u substitution. Easy enough. U equals 1 minus x. Du would be negative dx. So we need a negative on the inside, negative on the outside to balance. We still need to change our bounds. So we have plug in negative 2, we get 3. Plug in 0, we get 1. And this is going to be 4 over u du. Integral of 4 over u is natural log absolute value of u from 3 to 1. We'll plug in our upper and lower bound. And we will need to simplify these as much as you can, which means combining natural logs if you can, simplifying down. So in this case, natural log of 1 is equal to 0. So we're left with just natural log of 3. All right. So let me know if you have any questions, and make sure you work on the worksheet. Have a great day.